this is X, and here is the Oracle engine, which is part of the entire Oracle system shown here. This is the layer part and its option. It's currently centralized as an approach, but can be easily extended. So yeah, we have the data stream, which is a collection of price feeds, fetching price at different intervals to ensure randomity and also like space out the prices. So the data stream takes in the price, conforms it to like an internal standard that we have. It's more of like an extended version of this, and then sends it to the price pool. So now you can see they are all separated because they are running on separate threads, and the price pool filters out the outliers. Also uses a dead letter queue so that we can always come back to track why we have those outliers. And then everything is centralized. There is a central login system that's taking note of everything, and then it goes to the aggregator. Now there are different aggregators that are spun out through each asset we support, and the aggregator collects the formatted price, sorts it, takes a note of deviation and filters out storm as well that the price will not catch out. Then from there we send it straight to the ambassador, which is more of our consensus layer, because the ambassador actually handles a bunch of different things. Firstly, storing the price as a raw price, and then sends a bunch of it after it's been aggregated from the aggregator to the consensus layer. It does a median based column and a moving window average algorithm to like calculate our own rate. From there, the new approved price is stored on DB and then sent to the layer. So the ambassador is the one taking note of everything here and is handling it with the storage, and yeah, so that way we are able to link the raw prices with our processors, which is very important for the audit feature. Whereas every form of price you get from our platform, we can always audit it to see all the price feeds that led to that aggregation and also the algorithm used. So from the layer is sent in a batch to the chain, one chain. And note also the consensus takes note of time deviation and also mean deviation.
So this is the price feed architecture. We have the relayer here. The relayer is an off-chain component that relays the price feed to the storage, release the price feed of a particular asset to this, like to the contract storage. And in the whole on-chain system, we have two main contracts. We have the price feed verifier and the main price feed storage itself. So the way the architecture is structured for the price feed is to ensure that this verifier can be changed later on when we support a decentralized system. Currently, we are using a sort of centralized system. So the relayer submits to the price feed verifier, and the verifier does some verification on the prices of the asset that is being released, then sends it to the price feed storage. So this is the architecture for the swap. So basically we have 4 main components, but we have 3 main contracts for the swap itself. We have the pair contracts. The pair contract is where the main swap and liquidity logic is on, and the swap is basically modeled after you swap with 2, but instead of using an AMM, like using the AMM formula, we are using the Oracle price feed. So basically the market price is determined by the Oracle, not like the AMM formula. So we have the contract factory. So basically the factory contains the swap. So to deploy a new like token pair, it is being deployed on the factory contract. And we have the router contract too. The router contract is just to, and basically you can do everything from the swap on the router contract instead of adding liquidity, removing liquidity, and swiping token. And based on how the swap is modeled, like there's a fee structure whereby the admin can set to accept fee and not to accept fee, but the fee structure per trade is 0.6% and 0.1% goes to the admin, that's us, and 0.5% go to the liquidity providers. And this is the user stories for each actor. We have 3 actors in the swap. So we have the liquidity providers, we have the traders, and the admin. So for the traders, let's start with the liquidity provider. From the liquidity provider, you can either provide liquidity or remove liquidity. So the best way to do that is to call the router contract, and on adding liquidity, the router contract confirm if the pair exists. If the pair doesn't exist, then it makes a call to the factory contract to create a new pair. So And also, liquidity providers can remove their liquidity by calling the collateral contract, and they earn 0.5% on every trade that is made on the peer contract. For a user, for a card trader, you can swipe your token, and you can swipe your token between like two arbitrary ERC20 tokens or a token and Ether. And the criteria for a token to be available in the swap is the factory contract supporting, like having a price feed that supports those two pairs of tokens, basically. And yeah, this is the main component here, the price feed, which is our in-house price feed.